Under a velvet sky, a rare celestial event is approaching. NASA warns of the rare cosmic swarm of 2025, known as 7 comets at once, a truly unprecedented gathering. Late 2025 marks this extraordinary moment. Not one, but 7 major comets are now rushing toward the inner solar system, their paths converging. Among them, the enigmatic interstellar visitor, 3I, Atlas steadily brightens, a silent specter from beyond our sun's influence. You watch these distant points of light, as if ancient omens are stirring from a long slumber. Such a convergence has eluded modern astronomical records, even when considering historical accounts like the single comet depicted on the Bayeux tapestry. Scientists still debate whether this cluster represents a true statistical anomaly or merely a transient observational bias within our current understanding. The potential for both profound discovery and unforeseen impact hangs in the vast darkness, inviting both wonder and a quiet apprehension. Let's dive in and explore how it all unfolds. Holding that thought, you consider the usual cosmic ballet. Astronomers typically track 1 or 2 bright comets in a given year, perhaps 3 in rare instances. This common rhythm of the cosmos establishes a baseline for expectation. The event of 7 comets at once, NASA warns of the rare cosmic swarm of 2025, fundamentally shifts this understanding. It describes an unprecedented convergence of icy bodies, a celestial gathering unlike any seen in recorded history. This year presents a profound deviation from the norm. 7 distinct cometary objects will sweep through the inner solar system within a mere 6-month window. This extraordinary density compresses centuries of skywatching rarity into a single, intense season. The sheer number challenges previous statistical models of cometary influx. Historically, grand comets like Hale-Bopp in 1997 captivated observers as singular spectacles. Its magnificent tail stretched across the night sky, a lone celestial performer. Halley's Comet, with its predictable 76-year return, also arrives as a solitary, anticipated guest. Even interstellar visitors, such as Oumuamua in 2017 and Comet Borisov in 2019, were unique for their exotic origins. They journeyed from beyond our sun's gravitational influence, offering fleeting glimpses of other star systems. Yet, these were also solitary travelers, brief and isolated encounters. The 2025 swarm, however, involves multiple solar system comets making concurrent perihelion passages. These are not visitors from afar, but residents of our own Oort cloud and Kuiper belt, now roused simultaneously. Their collective arrival distinguishes this year from all prior analogs. This unusual influx feels as if the universe has opened a cosmic floodgate, releasing a sudden, dense cluster of its icy inhabitants. It is as though a hidden mechanism has synchronized their journeys, propelling them inward at once. The cosmos offers a profound, unexpected display. Scientists still debate whether this represents a true statistical outlier, a mere chance alignment of trajectories. Some theories suggest a recent gravitational perturbation within the distant Oort cloud, dislodging a group of icy nuclei. Others argue it is merely a long overdue clustering, a natural ebb and flow of cometary populations. The data refuse to agree on a single, definitive trigger for this particular phenomenon. One of these 7 objects, Comet C 2023, A3 Suchinshan ATLAS, is projected to pass approximately 0.58 AU from Earth. This distance equates to roughly 86.7 million kilometers, a relatively close encounter for such a celestial body. This proximity offers a unique opportunity for detailed observation. To grasp this vast yet significant proximity, imagine a journey across the entire continental United States. That distance is like traveling across the US nearly 17 times, emphasizing the immense scale of space. Yet, for astronomers, 86.7 million kilometers is a mere stone's throw in cosmic terms. The initial discovery of these objects did not occur simultaneously, but rather through a meticulous, ongoing process. Ground-based observatories and automated sky surveys, like Pan-STARRS and Atlas, made the early sightings. These robotic sentinels continuously scan vast stretches of the night sky, searching for faint, moving points of light. Once identified, follow-up observations confirm their cometary nature and refine their orbital paths. This involves tracking their movement over several nights, looking for the telltale glow of a developing coma. Early alerts from these surveys allow for more detailed study and preparation. The collective recognition of their simultaneous inner solar system passage emerged only recently through sophisticated orbital modeling. Predicting the precise timing of their closest approaches is complex. It involves accounting for subtle gravitational perturbations from planets and other celestial bodies. Tracking these celestial nomads requires a diverse array of instruments and global collaboration. Large aperture telescopes provide detailed imagery, capturing the faint glow of the cometary coma. Spectrographs analyze the light, revealing chemical composition and volatile content. Space-based observatories offer an unobstructed view, avoiding atmospheric distortion that can blur ground observations. The Hubble Space Telescope provides unparalleled resolution, while the James Webb Space Telescope offers infrared insights into their icy cores. Each method contributes a unique piece to the larger puzzle. The sheer number of objects in 2025 multiplies this observational challenge, demanding careful prioritization of telescope time. Astronomers must coordinate across global networks, sharing data and insights in real time. This collaborative effort is a testament to modern astronomy's capabilities. The historical record offers few direct parallels to the 2025 event, making it an exceptional case study. The Great Comet of 1811, visible for over a year, was a magnificent but singular sight, inspiring awe and scientific inquiry. Comet Hyakutake, in 1996, another comet of the century, also arrived alone. These past events, while spectacular, did not involve a concurrent group of multiple independent comets. The 2025 scenario is different. It represents a statistical clustering that suggests a potential underlying mechanism, perhaps a past gravitational nudge in the Oort cloud, or a passage through a denser region of interstellar gas initiated this influx. This event challenges the perceived randomness of cometary arrivals, hinting at a subtle, unseen orchestration within the solar system's distant reaches. It is not a single, grand spectacle, but a complex, multi-object celestial play unfolding before our eyes. The implications for our understanding of solar system dynamics are profound. Ancient cultures often viewed comets as powerful omens, portents of change or disaster, a quirky detail woven into human history. The Bayeux Tapestry famously depicts Halley's Comet, appearing just before the Norman conquest of England in 1066. King Harold is shown looking skyward, the comet interpreted as a sign foreshadowing his defeat. This historical footnote reveals humanity's enduring fascination and our tendency to imbue cosmic events with terrestrial meaning. Even today, despite scientific understanding, a comet's passage can stir a primal awe. A swarm of 7 comets amplifies this ancient resonance, prompting deeper reflection. The philosophical framing of this event invites deeper contemplation about the solar system's dynamic nature and its vast, unseen reservoirs of icy material. You are witnessing a phenomenon that transcends human timescales, connecting us to the primordial chaos of the early solar system. These comets are time capsules, carrying pristine material from billions of years ago. Their sudden influx offers a rare opportunity to study these ancient remnants en masse, asking what secrets they hold about planet formation. Do they contain the building blocks of life, preserved in their icy cores? The collective arrival prompts a reevaluation of our cosmic neighborhood. It makes us question the true extent of the solar system's active population, hinting at a more dynamic and less predictable environment than previously assumed. The universe is not static. It is a place of constant motion and occasional, breathtaking surprises. This swarm is a powerful reminder of that dynamism. It sparks a sense of wonder, inspiring a quiet humility as we observe the vastness around us. We are but observers on a small, blue planet, and the cosmos continues to unfold its mysteries, sometimes in unexpected numbers. The pattern grows clearer, yet stranger. From this point, your gaze narrows on 3I, Atlas, the true enigma at the heart of the 7 comets at once. NASA warns of the rare cosmic swarm of 2025 event. Unlike its companions, Atlas arrives not from the familiar outskirts of our solar system, but from the deep, dark void between stars. Its presence transforms a rare gathering into an unprecedented interstellar visitation. You watch as astronomers trace its path, a hyperbolic trajectory that unequivocally proves its unbound nature. This comet does not merely orbit the Sun, it sweeps through, a transient visitor on a journey spanning light years. The gravitational embrace of our star is merely a momentary bend in its endless galactic voyage. Atlas stands apart from even the most distant Oort cloud comets, which remain gravitationally tethered to our system. Its predecessor, 2I, Borisov, offered a fleeting glimpse of interstellar ice, but Atlas presents an even more compelling spectacle. NASA scientists highlight its unusual brightness, far exceeding what models predict for an object of its estimated size. The chemical signatures emanating from Atlas further deepen the mystery, exhibiting a composition unlike any comet observed originating within our solar system. Spectroscopic analysis reveals a unique cocktail of volatiles, suggesting a birth in a stellar nursery vastly different from our own. This alien chemistry challenges long-held assumptions about comet formation across the galaxy. It travels through the cosmos as if carrying secrets whispered from another star system, its bright coma a beacon of distant origins. The very light it reflects tells a story of an environment where ice and dust coalesced under conditions we can only speculate about. Its passage offers a rare, direct sample of material from beyond our solar neighborhood. Scientists still debate whether Atlas's unusual brightness stems from a higher abundance of supervolatiles or a more porous, easily sublimating surface structure. Its orbital eccentricity, measured at approximately 1.000001, confirms its hyperbolic path with astonishing precision. This slight deviation from a perfect parabola signifies its escape velocity, propelling it onward at speeds reaching 55 km/s, a speed that could carry it across the entire continental United States in under 2 minutes. Historically, ancient cultures often viewed comets as celestial messengers, harbingers of change or omens from distant realms. While modern science dismisses such superstitions, the arrival of an interstellar object like Atlas evokes a similar sense of wonder and profound otherworldliness. It is a true wanderer, unburdened by solar allegiance. This solitary voyager, now a centerpiece of the celestial gathering, offers an unparalleled opportunity to study the building blocks of other star systems. Its distinct characteristics make it not just one of 7 comets, but the most compelling subject of the entire swarm. The pattern grows clearer, yet stranger. Holding that thought, the focus shifts beyond the singular spectacle of Comet Atlas, the initially brighter visitor that first captured astronomical attention with its early luminosity and intriguing, somewhat erratic trajectory. You observe the wider phenomenon now unfolding across the celestial sphere, a truly exceptional event. NASA warns of the rare cosmic swarm of 2025, a collective arrival of 7 comets at once, each charting its unique, icy course toward the inner solar system, from the remote, frigid reaches of the solar system's outer boundaries. These additional 6 visitors, less heralded individually than the more prominent Atlas, yet equally significant in their scientific potential, form the true, complex core of this unusual celestial gathering. Their combined presence contributes to an unprecedented cosmic ballet, an intricate display of icy wanderers converging from the solar system's distant, dark frontiers, a spectacle rarely witnessed by humanity with such clarity and scientific scrutiny. This confluence of multiple comets represents a scientific opportunity of immense proportion, allowing researchers to study a diverse population of these primordial objects simultaneously, leveraging a global network of advanced observatories that meticulously track their every subtle movement and evolving characteristic. The initial detections, often faint and ambiguous signals captured by automated sky surveys, gradually coalesced into definitive orbital paths, painting a clearer, albeit still evolving, picture of this impending celestial traffic jam, a cosmic convergence that challenges our assumptions about cometary influx rates and the long-term stability of the solar system's various icy reservoirs. This extraordinary event pushes the very boundaries of predictive astronomy, forcing a profound reevaluation of current models and inspiring new theoretical frameworks. Each of these 6 comets, while appearing as typical solar system bodies in their fundamental composition, carries its own distinct chemical signature, a frozen record of its ancient birth, locked away for eons in the deep freeze of space, preserving invaluable clues to the early solar nebula's composition and thermal history. Their nuclei, hidden beneath layers of dust and ice, range in size from a few hundred meters to several kilometers across, comparable to small asteroids or even minor moons, yet they are far more volatile and dynamically active. They are composed of rock, dust, and various frozen gases like water, carbon dioxide, methane, ammonia, and even more complex organic compounds, forming a rich, volatile mixture that becomes intensely active near the Sunday. As they approach the sun's increasing warmth and intense radiation, these volatile ice components sublimate directly into gas, streaming away from the nucleus to create their characteristic comets and extended tails, a spectacular display of outgassing that can span millions of kilometers, far exceeding the size of planets. This outgassing is not merely visual, it provides crucial spectroscopic data, revealing the precise molecular composition of these ancient bodies, a window into the chemical environment of the early solar system. The comets in this swarm, including the prominent Comet C, 2023, A3 Tsuchinshan Atlas, are projected to reach their perihelia at various points throughout late 2025, with each making its closest approach to the Sun within a narrow temporal window. Comet C, 2023 A3, for instance, is expected to peak in brightness around October 2025, potentially reaching a magnitude that makes it visible to the naked eye from dark sky locations, a rare treat for sky watchers. Its closest approach to Earth is estimated at approximately 0.58 AU, or about 86.7 million kilometers, a distance that, while safe, allows for detailed ground-based observations and potentially even radar imaging from facilities like Arecibo or Goldstone. This proximity enhances the resolution of data collected, providing unprecedented insights into its surface morphology and internal structure. Another notable member of the swarm, Comet C, 2024 SOHN, ATLSE, is anticipated to follow a similar path, with its perihelion in late December 2025. This comet has shown early signs of increased activity, with a developing coma observed through telescopic surveys, suggesting a volatile rich composition that could lead to a spectacular tail display as it nears the Sunday. Its estimated nucleus size is around 2 kilometers, making it a substantial body capable of producing a significant outgassing event. The collective brightness of these comets could create a unique night sky vista, with multiple faint tails visible simultaneously under optimal conditions, a sight not witnessed in recorded astronomical history. The remaining comets in the swarm, such as C, 2024, R2, Pan-STARRS, and C, 2025 Ione, Neowise, contribute to the diversity of the event. Each has its own orbital inclination and eccentricity, meaning their paths cut through the ecliptic plane at different angles, providing a three-dimensional view of cometary dynamics. This variety allows scientists to study how different orbital parameters influence outgassing rates and tail formation, enriching our understanding of solar-wind interactions with cometary material. Ancient skywatchers, lacking modern instruments, often interpreted such multiple cometary appearances as profound omens, a quirky detail from history that adds a layer of cultural resonance to this modern event. Scientists still debate whether the simultaneous arrival of these comets is a mere coincidence or indicative of a larger, underlying pattern in the Oort cloud's dynamics. Some theories suggest a recent gravitational perturbation, perhaps from a passing star or rogue planet dislodging a cluster of icy bodies. Others argue it's a statistical fluke, a rare alignment in the vast randomness of space. The data refuse to agree on a single explanation, leaving room for ongoing research and speculation. The pattern grows clearer yet stranger. Holding that thought, you consider the profound implications of the 7 comets at once. NASA warns of the rare cosmic swarm of 2025 event, a celestial gathering that pushes the boundaries of observational astronomy and demands unprecedented coordination. The simultaneous presence of multiple comets requires a meticulous, multifaceted approach to observation, leveraging a global network of telescopes and space-based assets. This event tests the limits of current technology and highlights the need for advanced, integrated systems to track and analyze such complex cosmic phenomena. Ground-based observatories form the backbone of this effort, with facilities like the Vera C, Rubin Observatory, and the Pan-STARRS survey playing pivotal roles. These wide-field telescopes scan vast swaths of the sky nightly, detecting faint objects and monitoring their evolution. For the 2025 swarm, they provide continuous coverage, capturing light curves and positional data essential for refining orbits. Spectrographs attached to these telescopes analyze the chemical composition of cometary tails, revealing volatile compounds that offer clues to their origins. Space-based telescopes complement ground observations, offering unobstructed views free from atmospheric interference. The James Webb Space Telescope, JWST, with its infrared capabilities, peers into the cold, dusty hearts of these comets, detecting molecular signatures invisible from Earth. Hubble, with its high-resolution imaging, captures detailed views of cometary nuclei and jets. These assets are crucial for studying the swarm's interstellar component, like 3I, Atlas, whose alien chemistry requires sensitive instrumentation. The observational challenge lies in prioritizing targets amid limited telescope time. With 7 comets active simultaneously, astronomers must allocate resources strategically, focusing on key phases like perihelion passages. Automated systems and AI-driven scheduling help optimize this process, ensuring no critical data is missed. International collaboration is vital, with data shared in real time through platforms like the Minor Planet Center. Scientists still debate the optimal balance between wide-field surveys and targeted follow-ups. Some argue for more dedicated comet hunting missions, while others emphasize upgrading existing infrastructure. The data refuse to agree on the most efficient path forward, but the 2025 event will provide valuable lessons. The pattern grows clearer yet stranger. From this point, the cosmic swarm of 7 comets at once. NASA warns of the rare cosmic swarm of 2025 transitions from a mere astronomical curiosity into a profound catalyst for deeper scientific inquiry and technological advancement. This unprecedented event offers an unparalleled opportunity to probe the solar system's ancient secrets, pushing the boundaries of our understanding of cometary science and the broader cosmic environment. You watch as researchers across the globe prepare to harvest a wealth of data, each comet a unique time capsule from the solar system's formative years. The primary scientific boon lies in comparative cometology, where multiple objects can be studied simultaneously under similar observational conditions. This allows for direct comparisons of their physical properties, such as nucleus size, rotation rates, and outgassing behavior. For instance, Comet C 2023 A3's estimated nucleus diameter of approximately 2 kilometers provides a baseline for scaling other swarm members, revealing variations in density and composition that hint at diverse formation environments within the Oort cloud. Chemical analysis stands to gain immensely, as spectroscopy reveals the volatile inventories of these icy bodies. Water ice, carbon monoxide, and complex organics like methanol offer clues to the primordial solar nebula's chemistry. The swarm's diversity enables researchers to map isotopic ratios, such as deuterium to hydrogen, across multiple objects, testing theories of water delivery to early Earth. This could reshape our understanding of how life-essential elements were distributed throughout the solar system. Dynamical studies benefit from the swarm's concurrent passages, providing a snapshot of how comets interact with the solar wind and planetary gravitational fields. Non-gravitational accelerations, caused by asymmetric outgassing, can be modeled with greater precision when observed across several bodies. This refines long-term orbital predictions, crucial for assessing future impact risks. The event also accelerates advancements in observational technology. Adaptive optics and AI-driven data processing are pushed to their limits, handling the influx of information from multiple targets. New algorithms for automated comet detection and characterization emerge, enhancing future sky surveys. Scientists still debate whether this swarm indicates a periodic influx from the Oort cloud or a one-off anomaly. Some theories suggest a gravitational perturbation from a passing star, while others point to galactic tidal forces. The data refuse to agree on a single mechanism, fueling ongoing research. The pattern grows clearer yet stranger. Holding that thought, the cosmic swarm of 7 comets at once, NASA warns of the rare cosmic swarm of 2025, extends beyond scientific inquiry, touching on profound philosophical and existential implications. This rare convergence prompts humanity to reflect on its place in the vast, indifferent universe, a small blue dot amid an immense cosmic tapestry. You contemplate the comets as ancient messengers, carrying echoes of the solar system's birth, reminding us of the transient nature of existence. These icy wanderers, forged in the primordial chaos, underscore the universe's dynamic, ever-changing character. Their simultaneous arrival challenges our sense of predictability, hinting at hidden rhythms in the cosmos. It evokes a sense of humility as we grapple with forces far beyond our control. Philosophically, the event invites contemplation of cosmic interconnectedness. Each comet, a fragment of the same ancient disk that birthed our planets, connects us to the stars. This shared origin fosters a deeper appreciation for the delicate balance that sustains life on Earth. The swarm also stirs existential questions about humanity's future. As we observe these celestial nomads, we ponder our own voyages into space, aspiring to become interstellar travelers ourselves. It highlights the need for stewardship of our planet amid the vastness that surrounds us. Ancient philosophers like Aristotle viewed comets as atmospheric phenomena, while later thinkers saw them as divine signs. Today, we understand their astrophysical nature, yet the awe remains. Scientists still debate the role of comets in delivering water and organics to Earth, potentially seeding life itself. The pattern grows clearer, yet stranger. In the quiet that follows, darker scenarios begin to emerge from the shadows of the seven comets at once. NASA warns of the rare cosmic swarm of 2025. You watch the simulated trajectories, each comet a potential harbinger of unforeseen consequences. While NASA emphasizes the low probability of direct impacts, the sheer number of objects amplifies the inherent risks associated with such celestial visitors. The primary concern lies in the potential for fragmentation. As these comets approach the sunday, intense solar heating can cause volatile ices to sublimate rapidly, leading to structural instabilities. A comet like C 2023A3, with its estimated 2 km nucleus, could break apart, producing a cloud of debris that persists in the inner solar system. This fragmentation increases the likelihood of smaller meteoroids entering Earth's atmosphere, potentially leading to enhanced meteor showers, or, in extreme cases, bolide events. Earth's orbit intersects with several known cometary debris streams, such as the Perseids from Comet Swift-Tuttle. The 2025 swarm could introduce new streams, persisting for years or decades. While most fragments would burn up harmlessly, larger pieces pose a risk to satellites and spacecraft. The International Space Station, for instance, might require evasive maneuvers to avoid potential collisions. NASA's Planetary Defense Coordination Office, PDCO, monitors these objects closely, but the multiplicity strains resources. Tracking seven comets simultaneously demands constant vigilance, with orbital predictions updated in real time. Any deviation, perhaps caused by non-gravitational forces like outgassing, could alter a safe passage into a hazardous one. Scientists still debate the cumulative effect of multiple comets on the solar wind and interplanetary dust environment. Some theories suggest increased dust loading could subtly affect satellite operations, while others dismiss such impacts as negligible. The data refuse to agree on the long-term implications. Ancient records, like the Chinese annals describing the 44 BC comet swarm, coinciding with Julius Caesar's assassination, highlight humanity's historical association of comets with calamity. While coincidental, it underscores the psychological impact of such events. The worst-case model imagines a chain reaction, one comet fragments perturbing another's path, leading to a cascading debris field. Though improbable, it underscores the need for robust planetary defense strategies. What if the trajectory we trust is only the surface of a deeper pattern? Holding that thought, the quiet contemplation of the seven comets at once, NASA warns of the rare cosmic swarm of 2025, gives way to a more unsettling layer of speculation. You consider the improbable synchronicity, the statistical rarity of seven comets converging in such a narrow temporal window. This clustering defies the expected Poisson distribution of cometary arrivals, suggesting perhaps more than mere chance at play. What if an unseen gravitational influence, lurking in the solar system's distant reaches, is herding these icy bodies inward? Theories of a hypothetical Planet 9, a massive world beyond Neptune, have long circulated. Its gravity could perturb the Oort cloud, dislodging comets in clusters. The 2025 swarm might be the observable signature of such a hidden giant, a cosmic shepherd guiding its flock. Alternatively, galactic tides from the Milky Way's spiral arms could exert a rhythmic pull, synchronizing cometary infall over millennia. Our solar system's position in the galaxy might be passing through a region of heightened gravitational flux, triggering this unusual influx. NASA remains cautious, attributing the event to coincidence, but the anomaly prompts deeper investigation. Scientists still debate the existence of Planet 9, with orbital models showing promise but lacking direct detection. The data refuse to agree on its mass or location, estimated at 510 Earth masses, orbiting at 400-800 AU. Ancient myths often spoke of hidden celestial forces, like the Greek titans banished to the underworld, influencing the world from afar. This resonates with the idea of an unseen planet shaping our skies. The worst-case model envisions this hidden influence destabilizing more than just comets, potentially sending larger bodies inward over time. The swarm could be a precursor to greater disruptions. What if the trajectory we trust is only the surface of a deeper pattern? And that is where uncertainty begins. Holding that thought, you consider the sheer statistical improbability of the event. 7 comets at once. NASA warns of the rare cosmic swarm of 2025. 7 distinct icy bodies, each on its own vast trajectory, converging into our inner solar system within a mere 6-month window. The odds against such a synchronous arrival, without a common origin or an unseen orchestrator, stretch the imagination. Astronomers routinely track countless comets, yet their appearances are typically sporadic, scattered across decades. This clustering defies the expected random distribution. It raises unsettling questions about forces we might not fully comprehend, forces capable of subtly hurting these cosmic wanderers. You watch the simulated paths, each one a unique ribbon of light, yet together they form an unexpected pattern. Could gravitational tides, emanating from a distant, undiscovered planet in the outer solar system, be responsible? Such a massive, hidden world, perhaps lurking beyond the Kuiper belt, might exert a slow, rhythmic pull on the Oort cloud, dislodging comets in periodic bursts. The idea remains speculative, lacking direct observational evidence, yet it offers one explanation for the observed anomaly. Alternatively, some theories suggest hidden dynamics within the galactic plane itself. As our solar system traverses the Milky Way, it passes through varying densities of interstellar matter and gravitational fields. A recent, subtle shift in our local galactic environment could theoretically nudge a cascade of comets from their distant reservoirs, sending them inward towards the Sunday. NASA, however, stresses coincidence as the most probable explanation. Over the vast timescales of cosmic history, even events with incredibly low probabilities are bound to occur. The universe is a grand casino, and sometimes the dice simply land on an improbable combination. This perspective offers a reassuring, if somewhat unsatisfying, explanation for the unusual swarm. Yet, the human mind seeks patterns, even in randomness. The clustering of these 7 comets feels less like a roll of the dice and more like a deliberate arrangement. It's as if an unseen hand had swept a section of the Oort cloud, sending its icy inhabitants on a synchronized journey towards the inner system. This feeling persists despite the scientific emphasis on chance. Historically, unusual comet appearances have often been linked to significant earthly events, shaping myths and folklore. The Great Comet of 1811, for instance, was so bright and long-lasting that it was seen as an omen, coinciding with the New Madrid earthquakes and the Napoleonic Wars. While we now understand the purely astrophysical nature of comets, the psychological impact of such a simultaneous swarm remains potent, tapping into ancient fears of cosmic portents. Scientists still debate whether the observed clustering of comets is a genuine statistical anomaly or merely a rare, but expected, fluctuation in orbital mechanics. The data refuse to agree on a definitive cause beyond pure chance. Some argue that our comet detection methods have improved so dramatically that we are simply seeing more of what was always there, while others point to the distinct statistical signature of this particular event. The implications of a non-coincidental swarm are profound. If gravitational tides or hidden dynamics are indeed at play, it would necessitate a re-evaluation of our models for solar system formation and evolution. It would hint at unseen structures or forces shaping our cosmic neighborhood in ways we are only beginning to glimpse. Such a revelation would shift our understanding of the universe from a clockwork mechanism to a more fluid, dynamically influenced system. The worst-case model, whispered in academic corners, considers a large, undiscovered object, perhaps a rogue planet or a brown dwarf, moving through the outer reaches of the Oort cloud. Such a body, even if it never enters the inner solar system, could gravitationally perturb a vast number of comets, sending them on a collision course with the Sun, or more worryingly, with the inner planets. This remains a highly speculative scenario, yet the statistical anomaly of 7 comets at once, NASA warns of the rare cosmic swarm of 2025, lends it a haunting resonance. What if the trajectory we trust is only the surface of a deeper pattern? And that is where uncertainty begins. From this point, the cosmic swarm transitions from a distant celestial spectacle into a profound scientific opportunity. The impending arrival of 7 comets at once, NASA warns of the rare cosmic swarm of 2025, presents an unparalleled chance for deep comparative study. You watch as astronomers across the globe meticulously prepare for a period of intense observation. This collective presence of multiple cometary bodies allows for simultaneous analysis, revealing insights impossible from isolated, singular encounters. Such a synchronized event offers a unique laboratory for understanding the solar system's ancient history. It promises to deepen our comprehension of these enigmatic icy travelers. The scientific windfall primarily lies in comparing their unique chemistries and dynamic behaviors. Each comet, a relic from the solar system's formation, carries a pristine record of conditions from billions of years ago. Analyzing their disparate volatile compositions, such as ratios of water ice to carbon dioxide, can hint at their precise formation locations. Scientists hypothesize that comets from the Oort cloud may possess different ice mixtures than those originating from the Kuiper belt. Observing these distinct chemical fingerprints simultaneously helps researchers map the distribution of primordial materials across the solar system's distant reaches. This comparative approach provides a richer context than studying any single object in isolation. Cometary dynamics also gain new clarity through this multi-object event. Tracking multiple trajectories at once provides an abundance of data on how these objects interact with the solar wind and solar radiation pressure. Subtle yet persistent non-gravitational forces, caused by outgassing, continually alter cometary paths. The collective observation of these effects across several bodies strengthens existing models that predict long-term orbital stability and evolution. Scientists still debate whether the current models fully account for every minute perturbation influencing these icy wanderers, particularly over millennia. This swarm offers a chance to refine those predictive capabilities. Beyond pure scientific inquiry, the swarm of 2025 sharply underlines the critical importance of planetary defense readiness. Tracking 7 distinct objects simultaneously presents a complex logistical and computational challenge for space agencies worldwide. This scenario acts as a vital exercise, pushing the limits of current detection, monitoring, and data fusion systems. It tests the global network of observatories and processing centers, revealing potential bottlenecks or areas for improvement in a real-world context. The ability to manage such a complex array of moving targets is a cornerstone of future planetary protection efforts. Observational cadence becomes paramount during an event of this magnitude. Ground-based telescope arrays, such as the Atlas and Pan-STARRS systems, must synchronize their efforts with space-based assets, including missions like NEOWISE. Daily or even hourly updates on positions and velocities are necessary to refine orbital parameters with increasing precision. This sustained, high-frequency vigilance ensures that no unexpected deviations or sudden changes in trajectory go unnoticed as these comets traverse inner solar system paths. The sheer volume of data demands advanced automated processing. Follow-up strategies involve the rapid allocation of telescope time and the swift execution of data analysis pipelines. Once a new comet is detected and its initial orbit established, a cascade of actions begins within the astronomical community. Dedicated teams prioritize spectroscopic observations and high-resolution imaging to gather detailed physical and chemical information within days. This rapid response mechanism ensures that crucial early insights are not lost, especially for objects with short visibility windows or those making close approaches. The speed of response is a key metric for readiness. Alert thresholds are finely tuned to distinguish between harmless celestial passages and potential threats, however remote. Criteria include an object's closest approach distance to Earth, its estimated physical size, and the statistical uncertainty in its predicted trajectory. While none of the comets in the 2025 swarm currently pose an impact risk, the exercise of setting and responding to these hypothetical alert thresholds is invaluable. It refines the established protocols for future, potentially less benign, encounters. This practice builds institutional memory and operational muscle. The discussion naturally extends to theoretical deflection and response concepts, though these remain purely conceptual for this particular event. Strategies like kinetic impactors, which would involve crashing a spacecraft into an asteroid or comet to subtly alter its course, are continually refined through simulations. Gravity tractors, utilizing a spacecraft's subtle gravitational pull to gently nudge an object over time, represent another promising avenue. The swarm provides a real-world testbed for the practice of identifying targets, calculating hypothetical interventions, and understanding the lead times required. This intellectual exercise informs future technological development. International cooperation forms the absolute backbone of any effective planetary defense. Data sharing norms between agencies like NASA, the European Space Agency, ESA, the Japan Aerospace Exploration Agency, JAXA, and other global partners are therefore crucial. A unified planetary defense strategy requires seamless communication, standardized data formats, and joint decision-making protocols. The coordinated tracking of the 2025 comets solidifies these vital collaborative frameworks, ensuring a shared understanding of the cosmic environment and a unified front against potential future hazards. You might recall that, in ancient times, the sudden appearance of multiple comets was often interpreted as a portent, a sign of impending change or upheaval on Earth. This historical context highlights humanity's enduring fascination and trepidation regarding celestial visitors. Today, the tools are different, but the fundamental drive to understand and prepare remains. The scientific community treats the 2025 swarm as if it were a complex, multi-layered cosmic exam, each question demanding careful observation and robust analysis. The pattern grows clearer yet stranger. In the quiet that follows the rare cosmic swarm of 7 comets at once, NASA warns of the rare cosmic swarm of 2025 offers a profound, final reflection. Our solar system remains a realm of dynamic, often unpredictable motion. Each luminous visitor, from the anticipated Comet Atlas to its more subtle companions, reflects a delicate cosmic balance. You watch their ghostly forms traverse the night, ancient travelers briefly illuminated against the profound dark. This event highlights the inherent fragility of our human perspective, fixed on a single familiar world. Simultaneously, it showcases the immense grandeur of cosmic timing and its intricate, unseen dance across unimaginable distances. The comets move through the vast, cold void as if whispering secrets from the solar system's primordial birth. Ancient cultures often viewed such celestial wanderers as powerful omens, portending great change. The Roman philosopher Seneca the Younger, remarkably, once proposed comets were not random fires but celestial bodies following their own distinct orbits. Scientists still debate whether this specific convergence of comets is purely coincidental, or if a deeper, less understood mechanism is at play. Some theories suggest a gravitational perturbation in the distant Oort cloud, while others argue for a mere statistical anomaly within known comet populations. The unanswered question lingers. Why now, in this particular year, and what deeper patterns still wait unseen within the cosmic tapestry? To understand 7 comets at once, NASA warns of the rare cosmic swarm of 2025 is to glimpse the vast unfolding story that holds us all.